So first, okay, as I already told you, is it visible?
Yes, sir.
Yeah, you see here, as I already told you, the first block is nothing but the input signal X, which we need to put in a vector. I will show you entire thing once more, but first let us see the implementation part. And we also know that the second part is nothing but the FFT. Call this to be part 2. Already I have given the abbreviations, so explanation in last class. This is part 1. And this is part 2. This is part 2, which is performing FFT operation. So if you want, you can see the help of it. So you see the help content is telling that it needs 3 input. One is X, another one FFT side, and the middle one whether we want shifted FFT or not. Okay, for you it is not very important. It is used for applications. Okay. In turn, the FFT signal give 2 output. One is FFT of the signal and another one any possible error generated or not. If you want, you can add a indicator to that output also. Otherwise, it is optional. So this is the third thing. What is the third thing I told you? Please see your notes and tell. What is the third part? The indicator. Correct? What is the third part?
Indicator.
Yeah. So this is actually graphical indicator and this is numerical indicator. Right? So what we are doing is we are taking the calculated Fourier transform of X from this block 2 and giving this output to 2 parts. One is waveform graph, that is graphical indicator. Another one an array, which is nothing but playing the role of numerical indicator. Is it clear to everybody?
Yes, sir.
Yeah. Let us go to the front panel and see the output. So this is input. This is Fourier transform numerical output. And this is Fourier transform graphical output. Right? So what I am doing is I am giving input. One dimensional vector it is, one dimensional array it is. I am giving all ones. 1, 1, 1. One, 2, 3, 4, 5, 6, 7, 8. Okay? 8 ones I am giving. I am executing this program. So I am getting some numerical output like this. Sorry, graphical output like this. Numerical output, graphical output, because this is a complex number, so we cannot understand the things about this Fourier transform from this. So what we need to do is we need to either calculate magnitude versus frequency and phase versus frequency, then only it is of some value. Otherwise, graphical output is of no value. But numerical output will give us the required information. This is nothing but x of 0. And this is nothing but x of 1. This is x of, capital X of 0. इसको small बनाना चाहिए. Okay, no problem. चलिए x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, ऐसे ही और बढ़ाइए इसको, just expand this 6, 7, sorry, and one more 8. 1, 2, 3, 4, 5, 6, 7, 8. This is not necessary. That's why you see it is looking that it is not initialize. It's not a part of array, right? Chali. Hope it is clear to everybody. Yes, no?
Yes, sir.
But are you able to observe something in this? This result is visible to you people?
No, sir.
No problem. I have given some software. Have you tried that?
सर वो नहीं हो रहा है सर वो.
क्यों? वो लिंक 30 days के लिए फ्री आती है आपको. खुलने का नहीं है. You need to install that program in your computer and that will there in your computer for 30 days. नहीं आने का सवाल ही नहीं है. चलो ठीक है. So I am just telling you this thing. Please note down in your notebook. FFT of x, the value of first element. So here I am feeding 1, 1, 1, 1, 1, all ones, 8 ones I am giving. चलिए ये पोजीशन में आउटपुट क्या है लिखिए 8. Are you writing? Please don't waste time. I want to finish most of the content of the unit 5 in today's class.
Yes, sir.
ले लिए?
सर सेम कॉपी करना सर ये.
हाँ यहाँ 8 लिखिए, बाकी के पूरे कॉलम में 0 लिखिए. It is actually 0 plus 0 I है, but you can simply write down 0. लिख लिया आप लोग?
Done, sir.
Done. Good. Any observation? Any observation from
Sir,
this example?
the
Fourier transform of a constant signal will give output only at one instant, and rest all are coming to be 0. That should be your observation. Kalli observe. Have you taken that?
Yes, sir.
हाँ, अब चाहे तो इसको 1 की जगह पे 10 लगा दो. Everywhere write down 10. देख लो accordingly answer. चलिए आउटपुट क्या आ रहा है एक्सपेक्टेड? कैन एनीबॉडी गेस? $80. Rest all 0. Okay?
Yes, sir.
Yeah. So that example, if you want, you can write even in examination, because it is looking to be a small content answer. So if you want to make this large enough, in that case you can add a typical answer to okay. Now sometime, can I go to block diagram?
1 minute, sir. Yes, sir.
Okay, now I'm going to block diagram. Please take another question. Write a program to find DFT of 2 sequence. Write a program to find DFT of 2 sequence. DFT of 2 sequence. Okay? Any idea how can we find out that? Let us try. So I am taking directly, or या फिर बता दो मैं आपको how to do that. To find out DFT of 2 sequences, मैं निकाल दूं. Can I remove this thing?
Yes, sir.
या फिर नीचे आ जाऊंगा, इधर आ जाऊंगा. Okay. To find out DFT of two sequence, we want two inputs, right? So take two empty arrays. I'm taking one. I'm calling it to be x1, and take another empty array. Call it to be x2. Two inputs again. Let us add a control to this array. Procedure is go to numeric, take a numeric control and put in this, and this become numeric array. Similarly, repeat the same thing for second input. Now, please acknowledge whether this is clear to you people or not.
Yes, sir. Clear.
Already we have seen this thing. So this is nothing but creation of 1D array or a vector. Now go to our block diagram. Let us look at making DFT of two sequences. Size बढ़ा देता हूँ इसको. So right click here on block diagram, search for FFT function. Already it is available. Can I copy from here? Okay, I'm copying from here. Control C, Control V, right? But when we see the help of this function, it accepts only one input and give output of DFT output of that signal. So how can we find out FFT of DFT of two sequence? So in order to answer to this question, what we need to do is we need to separately find out DFT of these two sequences. Okay, using two different Fourier transform functions. Okay, and separately we can write create indicators. Create indicator. Now this become DFT of two sequence. You may ask me a question, so why this type of question is asked? Why there is a need to find out DFT of two sequences? In which application this type of requirement is there? The answer is, so we all know that convolution in frequency domain is nothing but what? I just take you to a whiteboard to explain you this thing. Whiteboard. Okay. Everybody see here? You see here. If suppose I have x1, so I'm using a Fourier transform box to calculate DFT of this. So I'm getting capital X1 of K. Similarly, suppose I have another sequence X2. So I'm using another block of Fourier transform to find out its DFT. So suppose we will get its DFT as X2 of K. So in which application DFT of two sequences are needed? Answer is nothing but convolution. Convolution, right? What is convolution? Convolution is nothing but this is convolution. Okay, summation n is equal to minus infinity to plus infinity x of k x1 of k into x2 of okay n minus k is nothing but convolution of these two sequences. Suppose this is represented as y of n. So this operation, if you want to find out with the help of Fourier transform, the procedure is like this: find out Fourier transform of both sequence, and suppose y of k is nothing but multiplication of these two sequences, x1 of k into x2 of k. Then to find out y of n, we need to again perform what operation? Again feed this through a FFT block, but in this case it is IFFT, inverse Fourier transform. Inverse Fourier transform of this result, then we will get what? Y of n. So this operation can be obtained with the help of individual Fourier transform operation followed by a multiplication operation followed by another Fourier transform operation. Is it clear? So the overall is called as convolution. If it is clear to everybody, I will show you convolution with the help of DFT of two sequence operation. This is already covered, I think, in your theory, right?
Yes, sir.
Yeah. Have you taken this thing? We will see this in future.
Sir, 2 seconds.
No problem.
Sir, I think we already did convolution in DSP, so I think
Yeah,
I
yeah,
have
yeah, yeah.
idea.
Yeah, yeah. No doubt, no doubt, no problem. Because we are going to see a program, huh? So this whiteboard content, please note, take it in your notebook.
Yes, sir. Done.
Okay. Now, what we need to perform now? We need to multiply these two sequences. Take a multiplier. These two are not really needed, so I am removing these two. Take a multiplier. I am increasing the font size. The output of this, you please connect to multiplier. So this output also, you please connect it to multiplier. And this become what? Our yk. So this yk again we need to connect it to one more Fourier transform. So, but this Fourier transform should be I inverse Fourier transform. So we will replace this with IFFT. Yeah, this one, right? So the output of this is nothing but convolution. This you please represent with Y. Okay. So what I will do is we will increase the font size of this program. Okay. Is it readable now?
Yes, sir.
So you can write title of this as convolution of two sequence. X1 a sequence, X2 sequence. So this become Fourier transform of X1, this become Fourier transform of X1. So multiplication of this is nothing but capital Y of K that we are feeding to IFT. It's not FT. Please mind it. It is inverse Fourier transform. So which takes the domain from frequency to time.
Yes, sir.
Done. So let us run this program. So let us restrict our size of sequence to be 4. So I'm giving 1 1 1 1 input, and this is also 1 1 1 1. I'm not using this. I'm not using this, right? So xn, please write down in your notebook, x1 n is inside your flower bracket, write down is equal to 1 comma 1 comma 1 comma 1, 4 ones write down. Similarly, x2 of n is equal to again 4 1 1 1 1. So y of n can be, how y of n can be expected? It will be equal to how much? So there is a formula for that. We need to do that thing. But one thing is very clear: y of n should contain how many samples? The length of first sequence plus length of second sequence minus 1.
8, 7.
7. Okay. 1, 2, 3, 4, 5, 6, 7. Right? Let us at least verify that. I'm running this. So our assumption is wrong because this convolution is not linear convolution, but it is circular convolution. Please make a note in your notebook. Our assumption is wrong because this is not linear convolution, but it is what? What?
Circular convolution.
Very
The
good.
convolution.
What is there in circular convolution? Length of input sequence and output sequence must be same. And we also know that with the help of Fourier transform, we can perform circular convolution, not linear convolution. Hope it is clear to everybody.
Yes, sir.
This is actually an application of Fourier transform. We have not covered convolution separately, but we have covered convolution under Fourier transform. Sometime a question on DFT of 2 sequence come, then you can use this program. So if it is over, we will move to next program, PSD.
Yes, sir. Over.
Right now. So in this program, actually, we will see two things. So मैं इसको यहाँ बाजू हटा देता हूँ. First, let us see PSD. Increase the font size. Okay. Is it clear now? Is it visible?
Yes, sir. Visible.
तो ये वाले को हटा दो यहाँ से. चलिए, you please concentrate here. This title is nothing but PSD of a given signal. मैं यहाँ क्या कर रहा हूँ मालूम है? What I am doing over here is, this is our function generator. We are already aware of, right? This function generator, frequency and amplitude I am changing from outside. So to plot the power spectrum density of this particular signal, what I am doing is I am making use of this express VI called as spectral measurement, right? Spectral measurement. So it is giving two output. One is PSD output, which we are connecting into waveform graph. Another one error output, which we are connecting into simply an indicator. So is it clear to everybody?
Yes, sir.
Yeah, I just go into this thing once more. So what type of signal we are selecting from this function generator? We are selecting a sinusoidal signal from this function generator. So its amplitude right now is 1. So its frequency is how much? 50 hertz right now. So let us go to front panel and observe the output. 1 second. Here we are. Okay. This is amplitude, this is frequency. I'm running this code. Once again. थोड़ा गड़बड़ हो गया. I'm running this code. One second, there is one more problem here. We'll see this thing later. Right. Let us concentrate in one program. Then we will move to another program. I'm running this program. Tell you, how much is the frequency? 50 hertz. How much is the amplitude? 1. You see, the power spectrum density is actually calculating the power of the signal. There is one formula for that we will discuss in next class. So with the help of that formula, the amplitude is calculated. So this amplitude is nothing but power of the signal. But what is frequency? Frequency is 50 hertz. You see, at that particular frequency, only there is one amplitude coming. That is called as PSD. The significance of PSD is we can see which frequency content is dominant in our information. the power of that particular information with respect to the frequency can be seen. So I just vary this frequency from 50 hertz to 100 hertz. I'm changing. Accordingly, you see the pulse is getting shifted. So आपको क्या दिख रहा है? What is this? You are able to observe from this diagram. Sorry, graph. At 100 hertz, you see spike is coming, right? Yes, no.
Yes, sir.
Yes, sir.
अब मैं 100 की जगह पे क्या करूंगा? 20 बना दूंगा. So what happened? At 20 hertz, a spike is coming.
Spike is coming.
20 की जगह पे 70 बना दूंगा. So at 70 hertz, I'm
70
getting.
hertz spike.
तो क्या मतलब हुआ है? What is the meaning of this particular graphical representation? The meaning of this graphical representation is we can get to know how many frequency content are present in the signal. अब ये एक ही है, इस वजह से एक ही स्पाइक दिखा. मैं क्या करता हूँ मालूम है? अभी क्या करता हूँ, थोड़े से नॉइज ऐड करके आता हूँ सिग्नल के अंदर. नॉइज जब ऐड करूंगा मैं, तो सिग्नल के अंदर कई फ्रीक्वेंसी कंटेंट आ जाएंगे. ऐड नॉइज. चलिए उसका पीएचडी कैसा दिखता है देखेंगे. चलिए देख रहे हैं आप लोग? आर एबल टू सी दिस थिंग? व्हाट इज द थिंग यू आर ऑब्जर्विंग नाउ?
सर थोड़ा अनवांटेड सिग्नल क्यों बता रहे हैं?
हाँ, अब देखिए मैं इसको स्टॉप कर दिया. यू सी at 70 hertz, no doubt we are getting one spike, but
Yes.
apart from that, we are able to see some spike at near about 180. At this
Yes.
point also, at this point also. So it means that this signal is actually under the influence of not one frequency but many frequencies. Vibration analysis में काम आता है. समझ गए बात? It is used in vibration analysis. It is used at many applications. So it is very useful tool of signal analysis. एक ही बात ध्यान में रखना. If we are not from the theory, it is if we are not covering this from theory point of view, if we are covering only from simulation point of view, so what we need to keep in our mind as minimum is the use of this particular tool is to find out whether any influence of many frequency contents are there in the signal or not. यानी समझो, आप समझ जाओ किसी की ऑडियो सिग्नल एनालिसिस करना चाह रहे हैं, तो एक आदमी की ऑडियो आ रही, बाहर बाजू से किसी और की भी ऑडियो आ रही, की क्या आएगी? दैट इफ यू वांट टू फाइंड आउट फ्रॉम माइक्रो लेवल or very small level, in that case we can go from PSD. Hope it is clear to everybody.
Yes, sir.
Yeah, please take this block diagram.
सर वो सिमुलेट सिग्नल के अंदर एक ब्लॉक है, देखिए उसमें क्या है सर? वो साइन है ना सर?
साइन लिखो बस.
ओके सर.
So, are you writing a point? What is the use of PSD? Or already you had taken earlier?
नो सर.
Take a point after writing this.
यस सर.
Yeah, PSD is mainly used for vibration analysis. PSD is mainly used for vibration analysis. Comma and continue. Mainly, it is used for calculating. It is used for calculating the power of the power of signal at different frequencies. The power of signal at different frequencies. The power of signal at different frequencies. Example लिखो. If a signal contain only one frequency, example लिखो. If a signal contain only one frequency, like sine, cos. If a signal contain only one frequency, like sine or cos, the PSD give only one spike. The PSD give only one spike at its fundamental frequency. At its fundamental frequency. Example 2 right now. Example 2 right now. If a signal contain many frequency components. Example क्या लिखेंगे बाबा? जल्दी से बोलो.
Sir, question क्या है?
If a signal contain many frequency components. Example. बोलिए क्या है example?
Audio?
Yes, but it is very vague answer. Specific, like sine with noise, right? Sine signal added with noise. ठीक है? आपका voice बिल्कुल सही है. Every signal contain many frequency component. There are very few signals in nature.
Audio received by a microphone with noise, surrounding noise.
Yes, बिल्कुल. Nature में all signals contain many frequency. In nature, all frequency signals contain many frequency components. Okay?
Got it.
Sir,
जी.
next class
Next class कौन सी है?
AI
हाँ कब है?
AI 12 to 1
हाँ आगे टीचर.
आएगी सर. एग्जिट में तो मालूम.
हाँ यहाँ तो नहीं दिख रहा है. ठीक है चलो. I will stop it now. Please share your attendance. अब ये खत्म तो हो गया ना?
हाँ सर.
If a signal contain many frequency component, then the output of PSD accordingly contain that many spikes. The output of PSD accordingly contain that many spikes. ठीक है?
Yes sir.
Okay. Thank you for joining.
Thank you sir.
Thank you, sir.
Yes, attendance mark. You all can leave now.